Hi students, in this class we see the relationship between electric field and potential. It is very important 2 mark question, right? Let us assume that we have a positive charge Q, right? So it is kept at some point origin or origin. We are keeping this point at origin, right? I want to move this charge from origin to some small distance dx. So here I have drawn large, but I want to move a small distance dx, right? So let us assume that I am moving this in the field, right, in the region where it has field. So we know that whenever we have a field, if we want to move the charge against the field, we have to do some work. Let us assume that dw is equal to force into displacement, because we know what is the relationship between work and force. Work is equal to force into displacement. So how much work I am doing to move a charge from Q to origin to some point A. Let us assume point A, the distance is dx. I am doing some work dw. dw is equal to f into dx. Why? D is a distance. How much distance I am moving? Small distance I am moving. Clear or not? So that is the thing. Now I put negative symbol. Why this negative symbol is very important one. Why I am putting negative symbol? Because I am moving the charge against field, right? So that means I am doing work against the field. So that negative sign indicates that one only. So we know F is equal to QE. Clear or not? So substitute that dw is equal to minus QE in, right? So QE dx. Clear? Okay, now you bring that Q this side, dw by Q is equal to minus E dx. We know what is potential V? Potential V is equal to work done per charge. So dw by Q is nothing but dV, right? Change small work, small potential, right? So this is the reason V is equal to W by Q. We have studied, right? Potential is equal to work done to move a charge from one point to another point. So dW by Q implies dV, right? So what is the thing we get next? If you simplify that, you will get dV is equal to minus E dx. This implies E is equal to minus dV by dx. This is very important relation, right? So what it is telling, electric field is negative of the negative gradient of potential, negative gradient of electric potential. What is the meaning? I will explain now, right? So what they are telling, you see here, we must know what is gradient. Gradient is nothing but change, rate of change, or simply maximum rate of change of some parameter. Maximum rate of change of some parameter. Here which one is changing? Potential is changing. So I put potential, right? So we know that what is rate of change of something? D by dx, that we studied in 11th standard, right? So d by dx nothing but rate of change of x. dv by dx means what? Rate of change of v with respect to rate of change of x. That is what your gradient. Why it is negative gradient? I have used the word negative gradient because we are having minus. So dv by dx is nothing but potential gradient. Why it is potential gradient? Because v is changing with respect to distance, right? Suppose dt by dx means, let us assume T is the temperature. That means it is temperature gradient. Clear or not? Right? So dt by dx will be temperature gradient. dv by dx, v is a potential, so potential gradient. E, electric field, is a negative. It is a negative of gradient of potential or a potential gradient. Both are same only. This is very important relation. E is equal to minus dV by dx. Why I need this relation? We know that it is easy to work with potential, right? Why it is easy to work with potential? Because potential is a scalar, whereas electric field is a vector, right? So this relates both the quantity, a scalar quantity with respect to vector quantity, right? So it is easy to work with the scalar. I need to have an equivalent version of vector. That's what potential gradient is giving. This is very important relation. Clear? Suppose this is for one dimensional x direction only, but in real time we are having x, y, z direction. So for 3 dimension, E is equal to minus dV by dx I. Let us assume x direction. Electric field is a vector, right? How potential is changing in the x direction? dV by dy. How potential is changing in y direction? Y direction it is j, we know. Similarly, how potential is changing in z direction? K. As usual, negative, right? So it is for 3D, 3 dimension equation. For 1D, E is equal to minus dV by dx. It is 1 dimension equation. Clear or not? So this we must know. So electric potential is the negative of potential gradient or gradient of potential. So when potential increases, what will happen? When potential gradient increases, electric field decreases. Yes or no? Because it is negative. So we know minus 10, minus 5. Which is bigger number? This is a big number. So if this is B, if this area is increased, E will be decreased. Right? Minus 10 is small, minus 5 is big compared to minus 10. So potential gradient, when potential is changed, right, increases, potential gradient increases, the electric field will be decreasing. This is a very important point. That's all about this session. If you are having any doubt, please ask me in comment section. I will clarify all your doubts. Thank you.